So this is the second part of two lessons on percent problems, different types of percent problems, how to solve percent problems, and just generally how we use the two vertical bars to solve any percent problem that we come up with. So the first type of percent problem that we had talked about was something along the lines of what is some percent of a number. In this case, what is 25% of 48? And so at any time that we solve a percent problem, we set up our two vertical bars, one from 0% to 100%, because that will always be the full length there, and then the other one of the same length starting at 0, but we leave the number up here blank for the moment. In this case, this is the number that we are finding the percent of. So we are finding 25% of 48, so 48 belongs at the top, and then we approximate 25% on the right-hand bar. When we approximate 25% on the right-hand bar, we can have an idea of where this number is going to fall on the left-hand bar. And so now we have everything that we need to solve the problem. We set up both as a ratio. Remember that in percentages, the percent number goes on top. It is a ratio with 100 as a denominator. And we follow the exact same pattern. The number within the bar is the numerator of this ratio because it's going to be written as a fraction, and the full length of the bar is the denominator. So a ratio of 25 to 100 has to be, because of the way that we set it up, the ratio of this x, whatever it is, to 48. So once we've done that, we can set those up as two ratios equal to each other, becomes a proportion, and then using either cross products or just multiplication and division with fractions, we can find that the answer that we're looking for is 12. 12 is 25% of 48. So that was the first type of percent problem. So we can manipulate that slightly, and we can come up to pretty much any variation of that type of percent problem. We started with the idea of the first type being something like, what is 45% of 80? What is 120% of 12? What is 100% of 90? What is 12.5% of 8? But we can change around what it is that we don't know, and our system will be exactly the same. It will always start out looking like this. The second type that we can look at is something like 25 is what percent of 50? So in this case, we are missing this percentage here. And the third type being 75 is 20% of what number? And in that case, we're missing the number up here. And the advantage of using the bars like this in the three different types of problems is that the bars, A, give a visual representation of the problem, and you can see, if you treat the left-hand bar as a number line, about what your answer is, and it can be adapted to serve any type of percent problem. So no matter what kind of percent problem you come up across, this method can be used to solve all of them. So let's look at the second type first. 25 is what percent of 50? Well, first we have to identify in any of these what we know and what we don't. What do we know? 25 and 50 are our two numbers, and what we're looking at is a what percent. So we don't know what percent that is. So over here, our percentage is going to be our unknown, but we can't fill in a percentage on the right-hand bar because we don't know what percent it is. Instead, we're going to take 25 is what percent of 50? Well, 50 is our overall number here because it's the number we're taking a percent of. And now we have to approximate between 0 and 50 where 25 would be on a number line, and it's going to be somewhere around here. So that sets us up here with a missing percentage. Once we have all that set up, and I've color-coded it here so you can see what we're talking about, 25, our number here, is what percent of 50? Once we have this, it's a matter of moving these into our two ratios, setting them equal to each other because we've set them up in these bars to be equal, and solving that proportion and finding out that x is 50%. Now the answer that you're going to get in this problem is x is equal to 50. But because, let me write that down here, x is equal to 50 is the actual number you'll get. But because x is in the top of the percentage ratio, we know that it actually represents a percent. And because our question asks what percent. The same technique applies to the third problem, which is 75 is 20% of what number? Again, we take what we don't know, what number, but we don't know, but that's not the number is 20% of something, it is 20% of that number. Because it's the number we're taking the percentage of, our unknown goes at the top. Our other numbers that we have are 75, which belongs here. And most importantly, our 20% goes down here, which is how we know what our 75 is. And now if we look at 75 here, we can see that our number's got to be somewhere in the 300, maybe even 400 range in order for this number line to work out. So we set our proportions equal to each other, 75 over x, 20 over 100 to represent 20%. Set them equal to each other and get x is equal to 375. Now in this case, 375 again represents the number that we're taking the percentage of. So one more time looking back, why are the bars useful for representing percents? Well, first they give a visual representation of what the problem is. So you can see it visually and know that if know whether or not your ratios and proportions are set up in the correct area, in the correct orientation, and it can be adapted to serve any type of percent problem that you want. So anytime that you see percent, you can use this technique. And so for any percent problem then, this is the actual strategy for using it. You're going to identify what you know and what you don't, because it's very important. You put those numbers and unknowns onto the bars. So first you have to know what you know, and then you put those numbers onto the bars, and then putting those bars into ratios in the same orientation gives you a proportion that you can solve with cross products that will give you the answer to your percent problem. And the last thing I'll mention is you have to understand what it is that your answer means. In this third type of problem, our answer was the larger number that we are taking the percent of. So in this case, 75 is 20% of 375. If we go back to the second type of problem, x is equal to 50 gives us the percentage that we're talking about. So not either of the two just plain numbers. We're looking at the percentage as our answer. And finally, in the first type of problem, it is the smaller number, some percentage of another number, so that number that we're getting after we apply the percent. So go ahead and take a look at these four problems. I've already numbered them for you so you know what they are. Pause the video and use those two-bar technique to see what you can do with these four problems. So now that we're back, let's go ahead and look at these four problems. Just like the last video, I have set up everything and marked everything here. Numbers 1 and number 2 represented the type of problem that we saw in the third type, where 42 is 60% of some number. Because it is a percentage of some number, our unknown for number 1 goes at the top of the bar. So 42 then goes on the bar somewhere, but we're not sure where until we put our 60% bar onto the percentage bar, carry across to see that we are looking at the same value, and get to 42. Now we can look at 42, see it's probably going to be less. The number that we're looking for is probably going to be less than double what 42 is, because 42 is a little bit more than halfway up the bar. Set up our two ratios, 42 over x equals 60 over 100, and solve using cross products to get to x is equal to 70. If you are unsure about solving proportions with the unknown variable, or if you just need some review, go ahead back to the writing and solving proportions video lesson, and that will give you the explanation there. For number 2, we're looking at the same thing. 12.5 is 25% of what number? Because we're taking a percentage of a certain number, our unknown is going to be at the top of our bars. So we know our 12.5, but more importantly for setting up the bars at the moment is the fact that we know our 25%. Now that we know our 25%, we can estimate where on the bar 12.5 is going to be. It looks like it's going to be somewhere in the range of maybe above 45, 50, maybe even as high as 55. Once we set up our proportions with each other, 12.5 over x is equal to 25 over 100, and then solve using cross products. X is equal to 50. Numbers 3 and 4, we're actually going back to that second type of percentage problem that we had, where we didn't know the percent, but we knew the two numbers. So in number 3, 72 is what percent of 50? In this case, we can't rely on the percent to give us the length of our bars. We can't just go say, oh, our percentage bar is about here, because we don't know what our percent is. But we know that it's a percent of 150, and that 72 is that number. So we estimate 72 is somewhere around, but not quite halfway to 150. So using that, we can estimate where our percentage is. And it looks like it'll be somewhere around 50%. And when we set up our two ratios, 72 to 150 is the same as x, our unknown percentage, to 100. Solve using cross products and get that we were correct. X is, in fact, 48%. What you should have gotten in terms of straight numbers when you answered it is x is equal to 48. Again, because x represents this top number of the percentage ratio, x is the percent. And then finally, for number 4, 9 is what percent of 180. Again, we start out with the of 180, which means that we're putting our number up here. 9 is a number we know, but 9 is very, very, very small compared to 180. So our percentage, translating over to our other bar, is not going to be very big. 9 to 180 is the same as x to 100, which gives us the answer of x is equal to 5, which is the answer that you'll get in terms of strict numbers. Remembering that x is the top part of the percentage ratio, x then is equal to 5%. So just as a quick review, for any type of percentage problem, you are going to identify what you know and what you don't know, because that will give you the understanding of what it is that you're going to put onto the bars. Every problem starts the same way. 2 vertical bars. The one on the right is our percentage bar from 0 to 100. The one on the left goes from 0 to some number. We may know the number, we may not. But once we know what we know and what we don't, we put those numbers onto the bars. It'll give us an estimate that we can make in terms of what our answer is going to be, and then put them into ratios with the same orientation to solve the proportion. Because this bar method is extremely powerful, it can be used to serve any type of percentage problem.